calculus kind of thing, the sum and difference formulas. Okay, in this last session today, I've actually kind of mixed in this using those formulas in the last couple segments, but in this last segment, what we're going to do is use the formulas some more. But what I'd like to do is to start off with seeing if you can come up with a sketch for the sine squared of x. And I want to show you, well, the answer is sitting right here in front of you, if you remember your material from previous chapters. If I'm interested in a sketch of y equals sine squared x, and I don't remember that, even after teaching this course many times. I don't remember that, and I don't want to always go grabbing my calculator. But here's what I do remember. And what I said a moment ago is it's actually sitting right here in front of you, based on chapter 6 material that we studied earlier. Let me set it up for you. Minus 1/2 cosine twice x plus 1/2. That's the same as sine squared x. So look at what you've got here, folks. You've got a cosine graph, don't you? With a period of, help me, pi, right?
Yeah.
Period of pi, a whole cycle in pi. And it's turned upside down, half as tall, and then lifted up by a half. I'll go over that with you in a couple minutes. But are you with me from the previous chapter? Don't forget that graph sketching stuff. When you see a formula like this, don't go, it doesn't have to be written that way. Look at what I did. I just turned it around. I just adjusted it a little bit, and here it is sitting right here, and it takes us back to some familiar territory. But what I want to show you is how I remember what this formula is. And here's how I do it. I'm really good with the graph of sine x, and so are you, okay? So if I draw a nice big graph of sine x, then I know the sine x readings at any location here are the heights, aren't they? Aren't those the heights as you move across this graph? Now imagine that you're squaring those heights, because that's what we're trying to do here, isn't it? Squaring those values. So if you're here at 90 degrees and you're squaring 1, it stays right there at 1. If you square 0, the height right here, it stays 0. If you square 0 over here, it stays 0. And if you square 0 over here, it stays 0. And if you square -1, it becomes +1. So I've got some points plotted for the square of sine x. Right? Now, think about this. When you're right up here near this top on the sine wave, it's a number near 1, isn't it? Near 1, right up there. What happens if you square something like 0.9? What is that? You guys are fast. 0.81, isn't it? Isn't that square staying close to that value? Yeah. What happens if you square a number that's near 0, like right in here? Like what if you square a 1/10? What's that? It's 100th. You guys are fast. Okay. Okay. Right? A 1/10 squared is 100th, isn't it? Now if I wrote it as a fraction, you'd see that real easily, right? Okay. Right? Quite a distinct difference between a 100th and a 1/10, right? Significant difference. So what that helps me with is it helps me remember what the graph of sine squared x looks like. Because when I start squaring these values near 0 here, it's going to diverge considerably from these values I'm seeing here. So it ends up doing this. And then when I'm up here near 1 in value, it's going to stay near 1. like that. And what I get is a nice smooth graph that looks like this. And lo and behold, look at that. Doesn't that look like an upside down cosine wave that's been squeezed and made an amplitude of just a half and lifted up a half at the same time? Well, here it is right here. Period, 180 degrees. Finishes a cycle. So there's a graph of sine squared x. So if you like that, that's a nice thing to remember. It's handy, it's easy for you to develop if you need to. If you wanted to come up with a graph of the cosine squared, you could do something very similar to that. Here's your cosine graph through a cycle, 360 degrees. If you square those values, it's going to look like that. It's going to look like this. There it sits. Period, 180 degrees. So the graph of cosine squared x is equal to a normal cosine graph, but its amplitude is a half. The period is now half of what it was, so that's a 2x, and then it's lifted up by a half. There's the formula. Okay. I have another problem I have time for. Let's do one like number 73 on page 484. And this will take you back a little bit, a couple of sessions. In 73 on page 484, ask us to figure out the tangent of an angle. And here's the angle, twice the inverse cosine of minus 3/5. If you can do this, you're in very good shape. Okay, so this is a challenging problem, and I just want to help you see that if you work your way from the inside out on your fundamentals, it's not too bad of a problem. This inverse cosine right here of negative 3/5, think of it as a what? An angle. Think of it as an angle, okay? So what you've really got going on here is trying to figure out the tangent of twice that angle. Okay? That's what we're looking for. So we come inside here and we have to deal with this inverse cosine first. Now that's a function which you studied previously. And if you're rusty on it or shaky on that, I want you to always think of your cosine graph, but stick with a domain that is 1 to 1 with an interval where the function is 1 to 1, passes your horizontal line test. Because the inverse of that is this inverse cosine. And these angles then are trapped in your unit circle between 0 degrees and 180 degrees. In there. So if the cosine is negative, I have to lay myself in which quadrant? I have to be, for the cosine readings to be negative, negative 3/5, it has to be here between 90 and 180 degrees. It has to be in here somewhere. And the cosine reading is x over r. So we have what we're going to do is we're going to draw ourselves a second quadrant angle with the x reading being -3, hypotenuse being 5, and the y reading here being a 4. There's your angle theta. We've got the triangle. Once we have the triangle, I'm going to come in here now and answer the question. The sine of twice the angle divided by the cosine of twice the angle is going to be equal to our tangent that we're looking for. We then go grab the formulas, twice sine theta, cosine theta for our numerator, and cosine squared theta minus sine squared theta for our denominator, and then we just drop the ratios in from the triangle. We have twice 4/5 times -3/5 divided by the cosine squared is going to be -3/5 squared is 9/25, and we're subtracting from that 4/5 squared, the sine reading squared, which is 16/25. We multiply numerator and denominator by 25, and we end up getting -24 over -7. Is that right? I think so. And so we end up with 24/7 for the tangent reading. Give me 2 seconds with the calculator. If I'm in, it doesn't matter which mode I'm in. If I'm in degree mode and I punch the original question, watch this, tangent of twice the inverse cosine of -3/5 I get this value, and I compare that with 24/7. Identical. Okay, on that note, we'll end class today, and we'll continue on with starting to solve equations in the next session.